Okay. So in terms of homework questions, what do you got? Anybody? I think those are the two most effective words for inducing quiet in a room. Any questions? How many of you have produced what appears to be a correct solution for number 2? No, at least one of you has.
So
I do.
Okay.
So y'all know where we are.
Okay, you can find it 1990.
No, I swear, Savannah must have struck it off.
They probably did. They played everything up.
I can find the other games where we didn't.
We tried.
Not that.
Yeah, 1990 it was. We beat them in Auburn and Alabama. We had some troops made up the Alabama State champs on it.
Because I went to Ole Miss for grad school, and I remember when I was there, they beat, I'm pretty sure they beat them.
They beat Bama again. Yeah, they beat us later. Andrew South.
What am I hearing? Are there like 20 people in that room? Anyhow, I just want to get a feel for where people are at. Or how far have they gotten?
Yeah, I've finished the first part of number 2. I haven't done the fourth order solution or anything like that for it though.
Okay. And that was discussed some last time. Okay. No. Any difficulties with that to bring up? Or?
So, as far as the convergence rate, as far as difficulties for the convergence rate of 2, I know that you. I was using for some reason I was using a 2 norm to calculate the error at first, and I kept getting a slope of like 1.5 when I did that. But then when I tried using an infinity norm and I got a slope of 2, which is what we were wanting. I'm not exactly sure why.
Okay. I think I have a hunch as to why. When you were so can you tell me exactly what you were doing? Like what norm? What were you actually taking the norm of?
The exact solution minus the computed solution.
Okay, so that was your whole error expression.
Yes.
Okay, then I can tell you why. Because the 2 norm is influenced by the length of a vector. As an example, suppose you have a vector of entirely 1s. Of course, the infinity norm of that is 1, no matter how many elements there are. Whereas the if it's a vector of length n of all ones, then the 2 norm is going to be the square root of n. So similarly, suppose the error, like the pointwise error, so the actual difference at each point between the exact and approximate solution was about the same. So then you're taking the 2 norm of the infinity norm of that would just be the largest gap. The 2 norm of that would be, I guess, in some sense, like a kind of an average gap times the square root of n. Now, the easiest way to deal with that, of course, yeah, the infinity norm is fine. I didn't really specify which norm to use. But you can use the 2 norm if you make it a relative error. So you divide by the norm, so you take the 2 norm of exact minus approximate, divided by the 2 norm of the exact, will cancel out the grid dependence. So if you do a relative error, then you should once again observe the second order convergence. And so it's those little things like that, the gotchas. But yeah, it's actually it's good that came up, so I can point that out. Okay. I'm looking at other things that are asked a question. I know that this particular problem asks for a lot of things. Okay. Has anyone got a start on 2C yet? Oh, someone disappeared. Oh, Chandler and Samson disappeared. Okay, not sure what's going on with them. Um, Did y'all seriously come to a class with homework questions, hoping that someone else would have questions, but not have any of your own?
I forgot we were,
Oh, okay.
to be honest.
Okay, well, I appreciate your honesty. That's fine. Okay. One proactive comment I'll make that may help head off questions that come later, and yes, I often do find myself in this position, is since this deals with the, a lot of this problem too deals with the center difference for a second derivative, which is second order accurate. But for this problem, it's not enough just to know that it's second order accurate. You need to know a little something more about the error term. And this isn't the notes, but something that warrants emphasis. That that's uxx at a given point, xi, is equal to the center difference approximation so all that over h squared. And then you need to know what the error term is. So minus, in this case, is h squared over 12 times the fourth derivative at that same point xi. Now, you could say it's an unknown point here, and then that's the end of it. But you can also say it's fourth derivative at xi itself, as long as you account for the next term, which is of order h to the fourth. So there is no order h. Oh, okay. Samson is here now.
Yeah, then I saw him. She's finding the packing space.
Oh, okay.
It was a graduate event and we attended that.
Oh.
Meeting, so when I realized the way so we decided to join the line. I wanted to go.
Oh, okay. So just like me, you all lost track of time. Okay. Well, that's good. That makes you feel better. All right. Yeah. Now, so in this case, the form of the error term turns out to be important. And here, the rest of it's not really necessary for the sake of a problem to know the specifics of this error term, except to know that it's order h to the fourth, not h cubed. Because what happens is you're taking Taylor expansions of u at these 2 points centered at xi, and that causes all the terms of, because you have u of x plus h and u of x minus h, all the terms of odd powers of h in the Taylor expansions end up canceling each other out. So that's why we only have even powers of h here. So knowing this error term is quite important. But if you're solving a PDE, minus uxx is equal to f, then this same error term is just that, like taking into account that use the exact solution, because if this is true, then f double prime is minus fourth derivative of u. So that's something that plays a role later in the problem. Okay. Because what you see is the way that the problem unfolds, you're starting with really the simplest scheme, that's second order accurate, and then you see two approaches to obtaining fourth order accuracy. One of those is what we talked about last time. That's using a stencil with more points. That's fourth order accurate. The other approach is you add a term to the right-hand side that has the effect of canceling out the second order error that the first scheme incurs, the one from part B. So by modifying the right-hand side, you can do that and get so then this part of the error will go away, and the leading error term will now be this. That's fourth order. Now, that is something that cannot always be done. It comes from having a thorough understanding of the error term. So that's why this kind of careful analysis of local truncation error is valuable. First and foremost, because you have an understanding of how accurate your method is in the first place, but it can also lead to ways to improve your method, because you say, oh, here's what the leading error term is. Can I get rid of that somehow? And then you figure out how, and then you have more accurate schemes. For example, in 2 dimensions, so Poisson's equation in 2 dimensions, if you use the most straightforward way of approximating the Laplacian, so basically just using this in x and y and adding them together, then this approach to canceling out the leading error term that you're doing in part 2C, let me check that. Yes, 2C cannot be done. But there's a different stencil that you can use for the Laplacian, where the error term is something that can readily be canceled out, like you're doing in problem in part 2C in this one-dimensional case. All right. One of my close friends, Margot Garrison, with one of her students, carried out what is called a modified equation analysis. That certain PDEs from fluid flow would have some strange behavior. That how the solution behaved depended on the actual grid you were using. So same problem, you change the grid, the solution behaves differently, which isn't supposed to happen. It's called a grid orientation effect. So the way she and her student got around it was doing this kind of Taylor expansion to see, oh, what's the error that's creeping in for one kind of grid or another, and then actually change the PDE to solve to account for this and got rid of the effects that way. And yes, I am just filling the time with useful information because no one's asking any questions. So I'm going to fill this void of something, dang it. Now that everybody's here again, then well, I guess half virtual, half in person. I'm done babbling for the time being, and I will open the floor yet again.
K or an R,
Where?
under H squared.
Oh, this?
Yes.
That's a 12.
Oh.
But now I can't see why you might think it was a K or an R.
Now I see 12, that's.
Yeah. 12 is actually my favorite number. I don't know how it started. It just is. No. But I did enjoy spooking on my classmates by counting in 12s as easily as ever people can count in 10s.
Mine's 14.
Oh, okay. That works. Yeah. Okay.
The guy I had a crush on in like junior high, his baseball number was 14. I graduated in 2014. My birthday's on the 14th. So.
Okay.
Of August. Yes, I did that.
Yeah.
Almost twins. My biological dad's birthday is the same as mine.
Okay.
Happy birthday, you have a kid.
Okay. Let's make that look more 12-like. I once went through a whole lecture. I was substituting for Margot back when I was at Stanford on the, and I apologize if anyone has heard this before. Probably should have told it during 610 because it was that kind of subject matter. I was teaching about something you all saw in 610, the Qr Factorization. In this case, it was a Graham-Schmidt method. So have A equals QR, and I'm using A, Q, and R all over the place, both uppercase for matrices and lowercase for their columns or entries. And Margot gave me her notes beforehand about this, and I looked at that, it's like, why is she changing notation? Instead of A equals QR, she's using different symbols to refer to everything. It's like, but I'm doing the QR factorization, so that's going to use that. And when I would often be writing something like this, like matrix A consisting of columns A1, A2, etc., and similarly Q having columns Q1, Q2, etc., I get all the way through to the end, and then someone in this 200-seat auditorium said that they could not distinguish between my A's and my Q's. And I got so frustrated, I just threw my chalk into the air. And like, so I did my best to clean up the mess. I was like, oh, so that's why Margot did that. Because she probably was in the same situation years before. And but like, I really want to stick with this, so I started exaggerating my Q's. Now, for you all taking 610, it was online, so it was a moot point. So maybe that's why I didn't bring it up then. But yeah, I ain't playing.
I do the curl at the end.
Yeah.
Yeah.
Okay.
I don't think that'll be an issue in Nigeria, because everyone writes the Q like that.
Yeah.
Curl cute, yeah.
Yeah.
Well, over time I did change how I write Z's. I started doing this
Yeah.
because people would think I was writing a 2. Although it's scary how multivariable calculus, if I did something like that and they'd think that the partial derivative symbol was a 2.
Yeah.
And they would ask this like weeks into the semester. It's like, you've been over this, no, this is my 2.
Students do that. Like, we tell them the same thing. I mean, a student sent my email yesterday, and I was about to explode when I saw the email. It was the same question over and over. You know how, like, they will come to the lab, do their homework, do not finish it, go home and continue. Right, but once you leave, it grades what you've done. But you can just go back, click on the homework and continue. In every class, I tell them that once you leave, this grades, but you can always go back and continue.
Yeah.
And after every class, like 2 students will ask me that same question.
Why is my grade 50? I'm not done with it yet.
Yeah, like every time. The same they asked me yesterday, like when I saw the email, I was really mad. Like,
Yeah.
if I was white, I'll probably turn red. I was really angry. I was like, let me just reply this red and say, the next person that's going to send me this email, I'm going to go back to prison. I typed that and I deleted it. I was like, oh, let me just-
Sometimes you have to unread it and then give yourself a couple hours.
You ask the same question. Like I said that announcement like 3 times yesterday in class. Only for me to get home and someone's emailing me like, he graded my assignment, I made a 50 and I've not completed it, he won't allow me to take it. I was like, what are you saying?
I've been there. I'm glad I work with very few students.
Yeah. Oh, your time will come. Yeah. One of my colleagues who was here on time was hired, but has since left. Well, he often told me stories about his dealings with students, and one in particular was where a student sent him a really long, scathing email to complain about everything he was doing wrong with the class and so forth. And so, yes, this certainly angered his professor, who started to type out a really long, equally scathing reply. But then, before sending it, reconsidered and sent a very short reply. He said, the fundamental problem here is that the final exam is in 2 weeks and it is comprehensive. So the student was no trouble after that. Well, as I was telling Chelsea before class started, I've had some students, especially early in my time here, who
I was really going to send that email yesterday, but I remember, like, if I do, it's going to get to Dr. Schroeder. I'm sure I can call him for the interview. The student, I think the students asked me if there was opportunity for extra credit when I was teaching March 1 for during spring. The students was failing and wanted opportunity for extra credit. And I was like, there was no opportunity for extra credit. I don't know how else I could have said that. I would have started 9 students. And the student said I came off I don't care if my student pass or fail. Very specific, and that got Dr. Schroeder and he called me for it.
Oh.
I don't know how I would have said that so that I don't hurt the student's feelings. Like you asked me, is there any opportunity for extra credit? And I said, no, there's no opportunity for extra credit. And
You go back and do your old work.
you understand, like the funny thing about that student was he was asking me after he has failed the final exam.
Oh.
What kind of extra credit do you want after the final exam? I'm like, no, there's no opportunity for extra credit. You just have to take it. You fail the class, just leave it and take it again next time. What do you want me to do? You want me to just upgrade you to a passing grade?
Yes, that's exactly what they wanted.
Like, I come off as someone that doesn't really care. He said a lot of details. And Dr. Schroeder was like, this student was very specific. Why do I think the person did that? I don't know.
Yeah.
I don't think there was specific.
What did they say that you said?
He said, Dr. Schroeder didn't tell me what exactly the student said. It was like, he used very specific words and said that he didn't care if my student passed or failed. That always come off as someone that doesn't care about anything at all.
Okay.
And I was like, why do I think the student said that? I was like, I don't know why the student said it. I really don't know. So I was like, if I send this email, it's definitely going to, because I haven't said anything wrong and I'm sure I've already heard about it. I had a note in my homework for class. The student couldn't find a date for a test, which is on the syllabus and announced every class. I'll tell you, I missed this one. So the students, either the student doesn't come to class because that's the one thing about online classes. Many of them don't show up and they don't watch the recordings. So the student doesn't show up to class, doesn't watch the recordings, and so doesn't know when the test is going to be. And that's in the syllabus. And just email me and tell me which day is the test. He didn't, he just went straight to Dr. Schroeder that my class is not properly arranged. And they have trouble finding information. They don't know when the next test is coming up. And I'm trying to make them use this online proctoring, examining.
Yeah.
And they are not comfortable using the examining. was like,
They emailed Schroeder?
yeah, I'm telling you.
Yeah.
They emailed Dr. Schroeder, and Dr. Schroeder said, and like once they emailed him, he emails me to schedule a meeting. But I know Dr. Schroeder like 3 or 4 times to ask me.
Oh, God.
Once they emails me, like I got a complaint about studying your class, I would like to talk to you about what you do to improve accessibility in your class. And then we'll go over the meeting, and I was like, did you do this? I did it. Did you do this? I did it. And at one point, it was like, everything I was going to suggest, written down, I was going to suggest to you, you're already doing it. So I don't know what the students are. I was like, I don't know either.
Yeah.
I don't know.
This is,
It's a simple thing. You don't know the date of the test, even your instructor. Like students do very weird things. I think Robert mentioned a student didn't know the date for his test, and named Miss McCarty. And Robert was teaching 167 that semester. I don't know, Miss McCarty know the dates. Like, how did you find Miss McCarty's information? I'm not your instructor's information. Students do very weird things.
this is why I don't actually read my teaching evaluations anymore, because if there is something in there that really should be brought to my attention, I know that Dr. Schroeder is going to read it.
Yeah.
And so I'll let him bring it up, and nothing like that has happened. So it's like, okay, I'm just not going to worry about it. No, because you have that, even in a whole forest of positive comments, you have that one rotten tree of a negative comment, and that's the one that sticks out, and
Yeah.
and that's the one you remember, and it could just ruin your day, or if happening after fall semester, your Christmas. So like, no, I'm just not going to do that anymore. It's just not worth it. As he continues to email us with all kinds of things to not pay attention to. Maybe I shouldn't post this video. Or maybe cut it off after a certain point. Because I can't edit it. Well, actually, no, I can't. Like I can edit what goes on YouTube. Whatever's in Microsoft SharePoint is a different story. But okay. In the meantime, well, I don't know if the virtual crowd is be able to hear all that, but and hopefully derive some entertainment from it. I'm sure they can relate, as we're all teaching in some capacity here. Have any other questions come to mind in the meantime? Or this is just evolving into a bitching session, which is productive in its own way. What time is it? Meanwhile, if I take a look at the notes, what's coming up next is more like actually brings back certain things from 610, because as you already see, we're solving A equals B problems, and there are various approaches to consider for doing that. And let's see. Oh, actually, what I see on the calendar for next time, like what I'm supposed to cover next week, it doesn't add up to a whole lot. In fact, it would only take one day to go through that. Okay. So I might make, well, I guess I could base it on what you guys are doing. Like, if you have questions on the homework, then we'll have plenty of time to deal with it. Or I can just, if not, I can keep plowing ahead through the notes.
You can go ahead and start homework too. That's homework.
Okay, so yeah, by this time, based on what I've covered so far, you've seen enough to do all of homework 2. Actually, let me make sure about that. Because that homework 2 is about spectral methods. Okay, and that consists of problems 4 and 5. And then homework 3 is problems 6 and 7. Okay, where, yes, like in problem 6, you actually revisit problem 2. It's the same PDE anyway, but solving it by a different method, a multi-grid method, and we've not seen that yet. So it'll be a while before you can do that one. Then, wait, what?
Like the spectrum method. I feel like we didn't spend a lot of time there. Or maybe I wasn't doing.
Well, it's just a 1 week. Well, but it was also 1 week on finite difference. So, yeah. And then, okay, but the very last problem is actually a 2D problem. Again, of Poisson's equation. Because later on, I have some time spent on time-stepping methods, like wrong cutter methods, multi-step methods, but I don't have any homework problems on that. But it's still very good stuff to know. Okay. So yeah, it's when it comes to spectral methods, it's definitely kind of bare bones. Like, okay, here's a general approach taken in the periodic case with Fourier basis function, Fourier transform, and the non-periodic case with Chebyshev polynomials. And yeah, I mean, whole books have been written about it, but I just don't have a material queued up for that. Although the problems that you'll see when we get to problems 4 and 5, they're pretty interesting cases that come up. Because if you solve problem 2, it's a problem was contrived so that you could actually come up with the exact solution. And when you get to problem 4, it's another Poisson's equation. Actually, it's not Poisson's equation. It's different PDE. In that case, also, you can come up with a formula for the exact solution. The problem is, it's a formula that cannot be implemented in MATLAB because of the limitations of floating point numbers. So that makes it difficult to judge accuracy. And sometimes it can happen. It can happen. Like if you have a exponential of a extremely small number, then you have underflow, for instance. Okay. So. All right. Well, I want to make sure, because also like later in the month we have fall break, so that's where we're only going to meet once that week. It's the week of October 18th. So, okay, so, but yeah, what I can do starting Tuesday is I'll just go through notes as far as I feel like, and you know, allow time each day for homework questions, and we'll get through all material in a relatively leisurely manner. Well, and it's still going to add up to a lot, but and the thing to keep in mind though as I go through all these things is that at the end of a semester, I get to quiz you all of them individually, oral final exam. What?
I'm not looking forward to it.
Understandable. Where you go through the notes. I mean, I'll give more information when it gets closer to that time. So.
Like all the times you've done that, I've always take it and then project instead.
That's always been an option.
Yeah, it's always been an option. You guys do this or you do project.
Well,
always going to regret it.
time to pay the piper. Okay. Like for example, things I was talking about not too long ago, about convergence, just consistency, stability, convergence. That's a gold mine of things to ask about.
Write that down.
Okay. Well, okay, it's 3:20 something. All right. One last chance for homework questions. Otherwise, I just go back to my office and play Wolfenstein.
Time to go to the bank after all.
All right, well, go to the bank. Okay. Good talk, everybody.
Yeah, so we went to this event the grad school was having.